Hello everyone, my name is Yang Yuhu, a lecturer at Chongqing University of Posts and Telecommunications. It is really a great honor for me to have this opportunity to present my paper here. The title of our paper is CHAMP Characterizing Undesired App Behaviors from User Comments Based on Market Policies. Most app markets have released strict developer policies, along with inspection and vetting process before app publishing. For example, Google Play has released a set of developer policies that cover 10 main categories. Each category stands for a type of violation that may be associated with various undesired behaviors. Apps that break these policies should not be published on Google Play. However, it is challenging to automatically check policy compliance for mobile apps. Actually, the user comments can be considered as a direct feedback from users who have experienced the apps, helping app market maintainers to identify user concerns and characterize the undesired behaviors that violate market policies. For example, as shown in this figure, two users gave 1-star rating for the app Signal Booster. One user complained that this app contains aggressive advertising behaviors, and the other even reported that this app might be malicious. In fact, these behaviors are also the undesired behaviors prohibited by the developer policies. So in this work, we investigate the correlation between user comments and market policies. We first collect a dataset of market policies and compile a taxonomy of the undesired behaviors described in them. We seek to collect policies from 9 popular markets, including Google Play and 8 top Chinese third-party app markets, as the policies defined by each market vary greatly. So we manually went through these policies and classified them into 5 main categories, including 26 distinct undesired behaviors. Then we propose CHAMP, an approach that adopts text mining and NLP techniques to identify comments that describe these undesired behaviors and classify them. The figure shows the overview of CHAMP. Concretely, the first step, we use a large-scale Android app repository to harvest a comprehensive dataset. In total, we have collected over 3 million user comments. In the training dataset building phase, we first merge the market policies that describe a same undesired behavior into a single document and identify a set of topics from them. Then, we randomly select 2% of the comments in our dataset and classify each comment into related topics. Considering that the automated classified comments may be not related to the undesired behaviors, so we further manually inspected the comments. Eventually, we obtained over 9,000 of labeled comments in total. In the semantic row extraction phase, CHAMP first groups the comments related to each undesired behavior into a corpus. For each corpus, it segments the comments into words, removes meaningless words, and sorts the remaining words to generate a word list. Then, based on a traversal operation, CHAMP could extract one or more keyword sets for each corpus. Finally, for each of the extracted keyword sets, CHAMP automatically generates semantic rows. We observe that behavior can be generally described by 2 keywords of different part of speech in a comment. And most UB comments are short and often include key phrases in specific orders. Therefore, the semantic rows not only contain keywords, but include order and distance constraints on matching the keywords. For example, this row means that ask appears before permission and their distance is less than 5 words. Eventually, CHAMP generates 320 semantic rows. The following step, we leverage CHAMP to perform a large-scale measurement study of UB comments. Our study is driven by the following three research questions. The first research question: to evaluate the effectiveness of CHAMP, we curated two benchmark datasets. This figure shows the distribution of our benchmark. Our evaluation results show that CHAMP is very effective in identifying UB comments. The average precision and recall are more than 90% for both of the Chinese benchmark and the English benchmark. Besides, we compare CHAMP with the text similarity approach. The results show that CHAMP achieves better results than the text similarity approach. Then, we apply CHAMP to our dataset. In total, CHAMP identifies more than 90,000 of UB comments, belonging to 2,440 apps. We find that about 61% of the UB comments were complained to have functionality and performance issues. The most popular behaviors of UB comments are fail to start, disruption, and payment deception. This indicates that UB comments are prevalent in the mobile app ecosystem, and the users who are sensitive to those policy violations are willing to report them in the comments. We further study the distribution of UB comments across comments with different ratings. We can see that the UB comments account for roughly 20% and 12% for the 1-star comment and the 2-star comments. As the crowd comments from Google Play contain a large amount of blank comments, we further eliminate such comments and report the results. This table shows the distribution of UB comments across different ratings and undesired behaviors in different app categories. We can see each row adds up to 100%, with each cell representing the percentage of a specific undesired behavior in the UB comments for a specific rating in an app category. For each app category, a behavior category box represents that the UB comments of a specific behavior category, and the number below the box shows the percentage of the UB comments in that behavior category. For app comments in Chinese markets, behaviors of the functionality and performance and advertisement types are most prevalent across all the ratings. Moreover, it is quite surprising that users complain about the security issues, but give the app a high rating. So we make efforts to manually examine all such contradictory comments and identify two major reasons. The first, the default comment rating of most Chinese app markets is 5-star. Thus, a number of users may only complain the app in the comments, but forget to assign a right rating. The second, it is quite possible that some users misunderstand the meanings of 1-star and 5-star. For example, we find that several users assign totally opposite ratings in all of their comments. In Google Play, users generally give 1-star in their comments when they find undesired behaviors in the app, even if the behaviors do not belong to the security category. Finally, we perform market-level analysis to investigate the differences across markets. We find that some apps have been complained of having undesired behaviors that are not captured by the market's policies. For example, over 60% of the apps in this market have undesired behaviors that are not listed in its market policies. This may open doors for malicious developers to exploit the insufficient vetting process. In conclusion, our paper presents the first large-scale study to investigate the correlation between user comments and market policies. We propose CHAMP, a semantic rule-based approach that effectively identifies UB comments. We apply CHAMP to a large-scale user comment dataset and observe that UB comments are prevalent in the ecosystem. That's the end of my presentation. Thank you for your listening.
Hi, everybody. Welcome back. I hope you enjoyed the video presentation of Yan Hu, which is here to answer your questions. So if you have questions for him, you can start typing them in the chat. If you want them to highlight them, you can push the question mark button so that we see them right away. Meantime, I take the opportunity to ask one of my questions. And I keep an eye also on the chat. So a curiosity that I always have is about the training. So in the CHAMP approach, you have a training step, which in your evaluation is quite significant. So I was wondering how expensive, if you know how expensive is the training in terms of, I don't know, time or computation or performance.
The training step, yeah. Sorry, you mean the training step? What?
The training the data set for in the building phase. So when you get as input the user comments, and then you have basically to analyze the data set to extract the comments, classify them, etc.
Oh yeah. The first step we have a training data set, conduct a training data set, and then we extract the keywords, key phrases for each sentence. Yeah, and the in the word segmentation phases, we will remove meaningless words, so the remaining words in descending order. Yeah, and then for each corpus, we will extract representative keywords. Based on their TF-IDF weight order, and compare the common set of each word, and then we will extract one or more keywords for each corpus. Yeah, and in the semantic rule generation phase, is based on our finding that we observe that the behavior can be generally described by two keywords of different part of speech. Yeah, so we will extract two keywords which are different part of speech, and combine the keywords of them, and then we can extract the keywords.
Okay. Yes. Yeah. Well, I understood the approach. Let me move to another aspects maybe. So in your presentation, you mentioned that you use a Chinese and an English benchmark, if I understand correctly, right?
Yes, we use Chinese and English benchmark.
So did you train or run the CHAMP approach on both comments in both in Chinese and in English? Is that I understood that correctly, or what do you mean?
For Chinese and English comment data set, we have extract different semantic rules for them. It's just two different phase. Yeah, it's just two different. We select to analysis Chinese and English comments because we want to know the differences between Chinese and English comments. The undesired behaviors, the difference of undesired behaviors in them. Yeah, we just want to know the differences. So yeah.
There is also a question from Sridhar in the chat. Do you consider emojis as well in your comments when trying to understand undesired app behaviors? It's a very good point, actually.
No. We don't consider the related emojis. Yeah, we just analyze the text. Yeah.
Yeah, well, I find it a very good comment because there might be a lot of users that have a thumbs up or thumbs down to comment on a certain app, for example. So you might want to consider that too in the future, maybe future evolution of the approach.
Yes, we will consider them. Yeah.
There is also a question from Ari. New IPS has introduced a requirement that all paper submissions include a statement of the potential broader impact of their work, including its ethical aspects and future societal consequences. So this is one of the, let's say, you can consider this one of the market policies, for example, for paper submissions. If this had been an ICSI requirement, what would your statement have been? That's a very good question, actually.
Paper submissions.
You want me to rephrase? Yeah. So suppose that your CHAMP approach was like an app, and then you have a policy that says potential broader impact of the work, including its ethical aspects and future societal consequences. So would your work fit within this policy?
I think we will use CHAMP with we will select temp as I think we will use CHAMP for the complementary to some of the program analysis. Yeah, and correlate with some app markets or some security requirements. Yeah.
Yeah, but I see. It's a little bit out of the box. So maybe after when we are finished, you can join the discussion room. And if Ari is there, then you can dig into this question further.
Oh, okay.
Yeah. So let's park for a second. I also had actually another question, if I may. We have a little bit of time. So how is it possible to integrate CHAMP in the current App Store? So how could you integrate that? Because your motivation for the work is to make it more difficult to miss undesired behaviors. So are you planning to integrate in App Stores so that you further help?
I think CHAMP is can provide insight to identify the boundary between policy violation behaviors and tolerable misbehaviors. So in the app market, I think.
Okay, maybe this is a